Okay, this is an acid plus acid problem. It might be a little harder to identify than others. This we know is an acid, the HNO3. There's one of our acids. But this, it doesn't give us a name for it, so it doesn't say something like hydrochloric acid. The fact that the pH is below 7 tells me it's an acid. So still an acid plus acid problem, which means I want to get moles of H from each acid and then combine them. That'll feel easier with the HNO3. You'll take your molarity, set it equal to moles over liters, and find your moles of your HNO3. Because it's 1-to-1, that will also then be my moles of H+. So from one of my acids, I found moles of H+. My other acid, it doesn't matter what the acid is, I'm never going to have to consider a ratio because we're already in terms of H. Here we were in terms of HNO3, I had to consider the ratio. pH, as soon as I do 10 to the negative pH, I have my H plus molarity. It's already H plus. It's not anything else. So my H plus molarity is 5 times 10 to the negative fourth, but I want to get all the way to moles. Molarity equals moles over liters. That's my moles. Since it was the molarity of H plus that I just used, I have my moles of H plus. Now, adding these together, this number is so tiny, it's still going to essentially look like 0.012, but you'd still want to show that work, that we are finding our total moles of H plus. And you get 0.012, and then a bunch of zeros, and then this, so 0.012. Our total volume, well, 20 mils from this, 15 from that, that's 35 mils, or 0.035 liters. Using my total moles and total volume, I can find the H plus molarity. And when I negative log H plus molarity, I get pH to be 0.46.